Well, this video is about this torch. I bought it in Lidl. It's just a high beam and also a little LED here and a 3-position switch, so on, off, on. And what I like about this, apart from price, is that you can literally place it anywhere. For example, it has magnets, you can see them here, so you can attach it under a bonnet from a car. And I was thinking, hey, well, this the surface of the magnets is gonna rub against the nice paint from my car and it's gonna scratch everything. But no, they are slightly tapered. You can see the offset in there. It's very nice. Also, it has a little bit of a peg system. I don't know if I will be able to activate it from here. You see, you can rotate, you can open it this way. You can see with the rubber cushions there. It's just amazing. It can rotate. It also has a hook here. And two things that I don't like is this light here, and also that it uses AAA batteries, and if you leave them connected, despite of the switch being off, it will just drain them. So I was thinking, why not upgrading this with components I already have, or cheap components? And that's going to be this video about. Let's start by disassembling this torch and by understanding how this circuit works. So what we have here right now is just the two LEDs here. This is the strip, and this one is the little LED. And then we have the 3-position switch and some resistors here. So my job here would be now to try to draw this in a paper. How do we do this? Well, you just need to follow the cables. Here's my circuit. I'll start with this LED beam or LED strip. The type is TL1267-A, just in case you want to purchase it. You can see here the positive, and here the other one is positive too. It's here and here in my drawing. Then one of the positives goes to the battery here, and the other one goes to this single LED, which is the HX1677. And then the negative part of this single LED goes to this board here, where the 3-position switch is. Therefore, it just follows the line and goes through a 1 resistor of 13 ohms and then to the position switch, which is here. It's right, this one. Then from the big LED strip, we have 2 resistors in parallel of 3.9 ohms together. So because they are in parallel, it must be 1.9-ish ohms. And then here what happens is just our 3-position switch. We can activate the LED strip, we can just leave it open, or here I just drew a terminator, and then this one here is the other option you have. Everything is connected through to a 3 batteries, AAA batteries that are connected in series. Therefore 1P because there is 1 row in parallel, and then 3S because there are 3 of them connected in series. The idea would be to, instead of using these AAA batteries, I would like to use a lithium polymer battery. But this, I would like to charge it using a USB, simple USB. I don't want to keep trashing batteries. Therefore, this charger here. And it's able to reach 2 amps as far as I'm aware of, and the link is in the description. It's a very cheap one you can buy from AliExpress. I added heat dissipator here because well, I did some tests and it got really hot at this point, so I think this will slightly help dissipating heat. That's good. Then we need to ensure that the circuit is fed with 4.5 volts. Therefore, I need something that, or a circuit that it will ensure that we will have this voltage all the time. Therefore, it is here. It's a step-up voltage converter or a regulator. And we also have a few more extras. One of them is, how do I know what's the level of this battery so I can I have an idea if I have to charge it or not. The battery is already protected. You have a protection circuit right here inside, so I don't have to worry about it. But I am adding this little board here with a little push button and some LEDs. So it will tell me roughly, you know, we have 4 LEDs, so it will tell me the battery level all the time. So whenever I press it, of course. So we have 4 LEDs, so 25% for each LED incremental. And then the last feature I would like to incorporate to this is, let's say I would like to disable the rest of the circuit, let's say the single LED and LED strip, whenever I am charging this battery. Therefore, I am adding a relay. Why this kind of relay? Because it's what I have. I'm using all things that I have, except this one. This one I just purchased, but the rest I already had in my electronics box. And this one, it looks like it could fit. Let's see. We'll figure out in a second. And the idea is that whenever I plug in the USB charging cable here, right here, I have these 2 terminals that will be connected to this relay, and it will be permanently connected. And whenever it's connected or enabled, it will disable these 2 LEDs. It doesn't matter what I do, it will never be able to connect this. So I am not interested in this part of the circuit for what I'm talking about, for what am I going to do. So what I will do basically is cut it here and perform my changes from this side on towards the right hand side. This part, it will stay like that. I'm gonna call it a load because it is a load. This is what you get. You can see in this part of the circuit is exactly what I used to have. So here's where I was just drawing my cutting marks, but then this is the part that I'm adding. Let's start with the step-up voltage converter. We need this. It's going to go instead of 4.5 to 5 volts. We need to test if it works. Otherwise, I will need to do something else. But this is the most important part because it will ensure that the right potential difference will be provided to this one. Think about water. The right pressure will be applied to the circuit. The flow that is able to do. Then from here I have a relay here, and here at the top is the battery, and here's the battery check circuit, and this one is the charger. Okay, let's talk about the battery. The battery charger, it has, as you can see here, it has 4 pins here on one side where the battery goes. You have battery plus, minus, and out plus and minus. This is what I have here, okay? And then on the other side you have the input. It's going to be USB charged, but you can do something else here. And I also checked that whenever you plug in something here and the USB ports, you are also providing 5 volts to these plus and minus signs on these sides, which is very beneficial in this case. So we have the charger here is this way, all right? And then the battery terminals will go to the battery right away. You can see the battery connected here. It's a 750 milliamps battery at 3.7 volts. And then, of course, I want to check what's the status, the battery level. So that's why I will take just in parallel and just connected the battery check circuit. I think I will do it even here, right here. You don't need all of these wires. Okay, that part is gone. Then you have the output. And here's the little thing about this circuit. The positive will go right away to the step-up voltage converter, and the negative is something we would like to disable whenever we are charging the battery. Therefore, it will go through this relay. This relay here, I think you can see it right here. It's normally set to a position which is this pin here and this one here. I don't know if you can see the diagram, but it's like this. So this will be always connected. So whenever it's not that the coil is not activated, the little actuator is not activated, this is going to be the normal position. Perfect. So this is what I like. I would like to, whenever the battery is connected and there is no charge, I'm going to be able to provide energy to this part of the circuit. However, when I apply, plug it in through the USB port, these 2 terminals will have also some potential difference, and it will activate this little coil that will make this switch to move upwards. And this is my terminator. This pin here, which is going to be this one here in my relay, is not going to be connected to anything. So whenever I'm charging the battery, I'm not able, whatever I do here, I'm not able to provide energy to this part. So this is the end result. I'm not gonna lie to you, I have tested it already. But I'm gonna show you what are the design flaws on this circuit. I am going to test it as it is right now. You can see here, I'm gonna just plug in the battery, bang, and it works. You can see that the single LED is just working fine. What are the problems here? Well, the problem is the following. When I want to switch on this beam light, I'll just switch it off, all good. I'm gonna switch on the beam light and you see what happens. That's it. The circuit goes dead. So I am going to do a little test because I believe, I don't know if the amount of current that is required by this beam light, it's a bit over the limit of this boost converter, which is between 1 and 1.5 amps. I just have no idea. So this is one of the problems. The second problem that I see here, this circuit here has a red light whenever it's charging the battery, and it's gonna become blue whenever it's charging, the charging finishes. Well, I think it's this one next to it. So I don't have any way to check what's the battery level while charging. Or do I? Yeah. I am a bit in a, I have a bit of a dilemma. I don't know if I could just grab a pair of wires and place an LED and in the other case so I can see when it's charging or when it's not. Because this little board I have here to check the battery is connected right in parallel to this battery here. So whenever we don't have a battery charging, so we remove this one, okay, now it's blue, it's the second LED, you can see, and I click here to see what's the battery level. Hey, it's showing me some kind of level. So yeah, I should have like an independent circuit. The other issue is when I have all this connected, there's no charging and I have everything switched off. What's the standby current that is consumed by this circuit itself? Because as you may remember, the switch is right here, and there's on one side of the switch you have this circuit, on the other side you have the LEDs. So there will be some standby current consumption or sleep current consumption that I would like to I would like for it to be 0 or very close to 0, because I am not planning to connect and disconnect this battery. Otherwise I'll forget about this charging circuit and I would just take the battery out and charge it somewhere else, and I can forget about the whole thing. The one I'm planning to use is this one here. This should be able to regulate the voltage, as you can see with this potentiometer, and also it should be able to withstand 2 amps easily. More findings. Since I could adjust the voltage of this one, I decided to place it in, and also this one was super warm. That means that there is a lot of current going through this PCB to this LED. This LED can handle it, but not the PCB. I will need to replace the resistors there, and I don't think I have them. And I want to keep it as original as possible. So what was my idea? To reduce the voltage till the moment I get the current consumption as before, which was 320 milliamps. And this works actually pretty well. Ah, by the way, I also replaced the LEDs here. I don't know if you can see here. Now you have green, yellow, red. I like it much more. So if I switch it on, you can see current consumption is even dropping. So I was looking at the wrong place. I was looking at the heat generated in the booster, but the heat generated was actually in where the where the 3-position switch is placed. So that PCB is our bottleneck. I could increase the power Yes, but I'm gonna leave it this way because it was already really good. I mean, look at that, it's too much. I think it's just perfect for me. And this looks safe. And this one I didn't take into consideration. But you may ask yourself, why is this happening? And when I placed 3 AAA batteries, these ones, everything works just fine. Well, because this is a LiPo battery and it has a 30C discharge rate. That means if it's 750 milliamps, it can discharge up to 30 times the thing. I mean, in the worst case scenario, so peak current. But no matter how much you demand, this is going to be able to provide to this one. So on the whole circuit, I'm using all silicon wires, 22 AWG, which work perfectly. This circuit, there's nothing to do with, this nothing, and then also with the relay, it's all okay. The relay can withstand up to 10 amps. So the only bottleneck is this guy. I could redesign it, of course, but and then go get more power. Yeah, but then the battery is going to drain super quickly. It already has 3 lines, you see? So I prefer to be on the conservative side for this very torch and keep it stable. I mean, it works and it has a lot of power already. And the more current you drive through these LEDs, the easier they will burn. So instead of white light, you will get yellow light, and at some point, that's it, done. And now it's not even warm. The circuit behind is just, oh my god, it's perfect. Do I want to deal with these 400 microamps whenever as a standby current consumption? Well, if I don't, the only idea I think I have in mind is just to break this wire here and place a little switch. So whenever I'm not using the torch, I can press the switch here too, and then this will get fully disconnected from the rest of the circuit, and that's all. I must admit, this simple project is quite a learning experience. Here I have my switch. The switch I was about to put on top of this one. So you already know that the electric design is not good, because if you need 2 switches, I mean, unless it's for safety, it's repeating component doesn't make sense, okay? What I said is, well, if I had to reduce the voltage here so much, why do I need this? If I remove that and I prove that the power consumption, the current consumption here stays within limits, and I wouldn't need this one and the other one. So I remove 2 components and stays as simple as possible. This one needs to stay for safety, for charging, because it's the part that the other torch didn't have, and then this one is there just as a battery level checker. So switch it on, bang. Yeah, it's not 350 milliamps, it's 490, 489, and you see it's going lower. So there is no problem at all. I love this thing. Don't you? I get a little bit more power, no heat whatsoever, 2 components less in my setup. By the way, the switch works. Okay. Now I'm gonna move to this side. Forget about this one. I have very small LEDs like this. Well, they are. I think this is red, and I'm pretty sure I can use it here. So I measure the voltage, it should be fine if I put them in parallel like this. I would like you to see it. Let's see, probably you will see. You can see, you see? So I think I should be able to remove the ones that are already in the board, drive very small cables from here to the rest of the housing, so we can check when our battery is fully charged. So let's tidy up here, remove this thing, and let's go from mockup. Let's see where I would place all of these components. Well, first of all, diagram update very quickly. Very easy. This goes up. That's all. Another thing I realized that the relay might be positioned in the wrong way. It should be the other way around. Well, you get the picture. Yes, it's wrong position. It's wrong drawn. So my fault. Apart from that, this is the top of the torch, where these mirrors and the glass go on the... So it goes here, on top, like this. I don't want to place any component inside because it will make the disassembling of this torch very complicated. So I'm not thinking about this guy. Unless I am sharing half of the features, but the component needs to remain this part here. So let's think about it. I don't know if it's fate or whatever, but the relay fits perfectly here. It's going to stay here, yes or yes. Then, where can I add the USB charging port? When you grab this torch, you do it through with the handle. Although sometimes I see myself doing it from here. So the charging port, I was thinking of placing it right here. There is a space to place it right here, like this. But I need to slide it, okay? But there is a volume conflict here with this corner, so I will just create a little slot here where I can slide this, and I also need to make sure that the tip of the USB charger is able to reach till the end of the bracket. Also on the other side I have these wires that I will need to rearrange somehow, but this is going to be this way. Then what about this little board here? This little board will go somehow, or I will move this way like this, or this way like this. I just don't mind the order, but it will slide like this. We'll need to make some room and you see some small cuts here, so we can slide all the LEDs. And this is the part that I think will share half the features between the top and the bottom case. So we have this one here and this one here. Of course the relay will stay here. I think I will just glue it with some hot glue just to keep it in place, so you'd have something dangling inside, yeah? Although I really doubt it will happen. Okay, the most scary bit for me right now, it's not this one, but it's this guy here. I was planning to place it where the old batteries go, yeah, but the lid has the shape of the hook from the torch, and there's a clear, I cannot close it, you see, there is a very big offset here. What I'm planning to do is remove material from here and here with the Dremel and try to leave 3 strips. Why I cannot remove everything and just leave a hollow space? Well, because of these holes here. These 2 are the support for the LED strip. These 2 are not super important, or these 3, but you want to keep the LED strip flat. That's why these 4 are here. You could say that 3 are enough. Yes, I agree. So I could remove these 2 or this one, I don't know. It's something I could do, yes. But this is the most scary bit, because I am not really sure that it will fit properly. Then of course the connector I will drill a little hole here or whatever, and then it will come here inside and you will have a lot of wires dangling here. How can we do this? Well, just to let you know that this part here is meant to be here, because if I place the PCB from the switch, it just lies perfectly. There's no even volume conflict. There's such a little clearance that I'm so happy. Then these 2 wires will probably be shortened, and then this is the LED strip. It just goes this way. This way. 1 and 2. It goes this way, and you see you have support here. Oh, sorry. There's another way. Oh, and then the front one goes this way. Use it like a slot. You slide it, and that's a bang. So I think I have something. The only thing now is to make some dust. Here it is. I just finished all the rework that was necessary in order to fit all the components, like the charger on the side. Here's for the LEDs. Yeah, it's not perfect, but I'm happy with it. And here in order to fit the battery. And here is another hole in order to direct the wire from the battery. Then I didn't want to film how I do this because it's material removal and it takes a lot of time, I don't have a CNC machine, and I don't have a model, and so on. So you need to do it very calmly, and it's very, very time consuming sometimes. So for what I did, not that much. Well, it's not perfect job, but anyway, I thought it would be useful if I show you the tools I'm using. So these are all the bits I'm using, and also a Dremel or something like that. So for removing rough material in a rough way, I mean, you can use these ones. For detailing features, these ones, and finally for grinding or engraving, these ones. I bought them in AliExpress, and they're good. For the price, they are quite good. I mean, I'm not gonna do some porting of an intake manifold with these ones, but for small jobs like these ones in plastic or aluminium, that's perfect. All right, let's put all together, and there we go. I managed to fit all the electronics. I was planning to use some hot glue, but everything is staying in place pretty well. I had some incidents. I don't know if you will see there in the button, the push button, but then I managed to do this these two LEDs, you remember? So we know that the battery is charging, or is it fully charged? There you go, two LEDs. Then all of these ones in order to check the battery level, you can see. And that's all, it all works. If I do this, it works, and it works. Now it's standby. I need to check the charging. The charging port is right here, and I know the charger fits. So the USB wire socket just is good. Things I also wanted to tell. Well, I had to trim this board for the 3-position switch button, and as you can see, I created two little features that are in contact with the charging board, and they serve as also as a fixation point, which is really good. Also, I got a little bit nervous. You can see how deep I went with these sockets, and this one is too big. So I can fill them with I don't know, perhaps epoxy, and work it out. But this is going to be for me and for the garage, and it's not going. Of course, this is not waterproof. Don't think that this is waterproof, because it's not. But from the very beginning, it has more holes than a cheese. And then this one is also too big. But hey, things to improve. Apart from that, now I'm gonna go for a reliability test. I'm gonna switch it on and check if this actually works properly without generating too much heat, because the electronics are very, 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 very close together here. I dare to say that the resistors from this board that used to get warm, they are directly in contact with the relay. And so I placed a little bit of insulating tape like this one, and I hope it's going to work just fine. So for now, what I will do, put it as it was in real life, and switch it on and leave it on as much as I can to see if it works. Also, the battery is fully charged, so I'll see how long does it last. Now it is charging, you can see. Very nice. Let's leave it there. It looks like it spent around 1 hour 15 minutes to charge a full battery, which is good. You can improve this timing, of course, using a better charger and a better charging board. But that's not my aim. So one thing I realized is, imagine I would like to spend a whole day working with this light switched on. Well, in that case, I will need to make the battery somehow serviceable, which is not as of now. So the idea would be to take the wire from here, from the charging board, and extend it to this part here, so I can exchange it. So I should be able to discharge one of the batteries in 1 hour 50 minutes, while the other one is charged in 1 hour and 15 minutes. Therefore, I can keep for a whole day with 2 batteries only, so exchanging them and charging them, which is good. But everything works.